Hi everyone. So the title for today's notes is Dividing Polynomials Using Synthetic Division. So remember last time we went ahead and we were doing dividing polynomials using long division. This is still super important, and honestly, long division is your go-to method 9 times out of 10. However, if you notice that you have some special situations, you can go ahead and use synthetic. The reason why synthetic is important is because, to be honest with you, it's a shortcut. And if you notice that if you recognize that you can use the shortcut, you always want to use it. This is why I'm going to spend my time teaching it to you. However, just understand or know this synthetic division does not always work. Like, you can't always use it, I should say. And then if you don't understand it, you can go to old reliable long division to give you the proper answer when you're dividing polynomials, okay? So when do you know that you can use synthetic division? Well, first of all, let me go ahead and let us write down what I just kind of verbally said out loud. So essentially, synthetic division is a shortcut. Sorry, that was not a nice S. So is a shortcut. And shortcuts don't work all the time, but if you recognize that you can use it because it's shorter. What are the two things that you need to recognize to use this shortcut of synthetic division? Well, the first thing you have to recognize is you should be able to recognize that that the divisor must be a polynomial of degree 1. Now, if you don't remember which term is the divisor of degree 1. Let's go back to these other notes. Remember, actually, did I write it on here? Oh, no, I wrote it on when I was doing the integer question on the side. But essentially right here, what's highlighted in yellow is what we call our dividend. What is like the second polynomial that's written after the division sign, that one is the divisor. So if you notice that your divisor has a degree of 1, that's the first indication that you can use synthetic. The second thing that you need to make sure of is that the divisor, or I should say the divisors, variable has a coefficient of 1. Now, what do I mean by this? So, like, let's say, like, if you have this polynomial, I don't know, x squared plus 3x plus 7, and I want you to divide it by x cubed minus 4. Well, here, you should recognize that your divisor, which remember, that's the second polynomial that's after the division sign, that one does not have a degree of 1. The degree here would be 3, because remember, the degree of a polynomial is the highest exponent that you see. So this would not be able to use synthetic division. What you would need is you would need it to just be x, or let me actually go back like this. You would need it to just be only, oh, well, that deleted it all, x minus 4, because now does this one have a degree of 1? It indeed does. Now, the second thing that you need to make sure of is that the divisor must also, wherever its variable is at, which in this case is just x, it has to have a coefficient of 1. So if I went ahead and I put a 4 there, that would no longer be able to use synthetic division, because I do not have a coefficient of 1. I have a coefficient of 4 in front of my x. So you always need to make sure that your divisor has only a degree of 1, so it can't have a squared, it can't have a cubed, or it can't have any other exponent with the x. And then in front of the x, the only thing that can be there is pretty much nothing, which is that whole idea of it being 1. So, like, I don't even remember on the other notes if I gave you any. Like, for example, this one, you wouldn't be able to use long division because of that exponent of 2. This one, you wouldn't be able to use long division because it has an exponent of 2, right? So sorry, not long, synthetic. And that was the only 2 examples I gave you. So actually, both of these, you would not be able to use synthetic. But I'm going to show you some examples where today you're going to be able to use synthetic division to solve. So it doesn't always work, but if you recognize you can use it because you're going to see in a second that it's a lot shorter. So, let's do an example. Let's say that I gave you 2x cubed minus 5x squared minus x plus 3 divided by x plus 3. Okay, so this one, you should recognize that you can use synthetic division because in my divisor, which is that second polynomial after the division sign, my degree is 1 and my leading coefficient of x is also 1. So you should recognize synthetic division here. However, let's say if you didn't recognize it and you wanted to go ahead and just use long. I'm going to go ahead and on the side do a little quick refresher of how to do long division to divide these polynomials. So I would go ahead and put x plus 3 on the outside. I would go ahead and put 2x cubed minus 5x squared minus x plus 3 inside my division symbol. And then I would go ahead and do the process that you guys already know how to do. For this one, you should realize that you need a 2x squared at the top. And then it's going to bring down to give us 2x cubed plus 6x squared. And then you're going to have to multiply all this by a negative so that this eliminates out. This ends up giving you negative 11x squared. And then I bring down my negative x and my plus 3. Then I go ahead and I figure out what needs to be multiplied by x to give me negative 11x squared. And that should be, you should be telling yourself negative 11x. Hence, that gives us negative 11x squared and a negative 33x. Multiply all of this by a negative 1. Again, I'm going through this fast because it's a quick refresher. This should then eliminate out. And then the x's simplify down to 32x plus 3. Your last step is to go ahead and put plus 32 at the top. And then it gives you 32x plus 96, I think it is. And then you go ahead and do all of this by a negative. This eliminates out, and then your remainder ends up being negative 93. So your final answer would be 2x squared minus 11x plus 32 minus 93 over x plus 3. Okay, or you can put a little plus sign there too, plus a negative 93 over x plus 3. Okay, that would be our answer using long division. If you didn't realize that you can use synthetic here, this is a lot of work. So if you recognize you can use synthetic, you're going to use it because in a second I'm going to show you how to do synthetic. The way synthetic works is this. Rather than having so this was using, I'm going to go ahead and put a line right here down the middle. And then this was using long division. Since the divisor has a degree of 1 and an exponent of 1, you can also use synthetic. We're going to go ahead and do synthetic on this side. So the way synthetic division works is like this. You're going to go ahead and do that division symbol, but you're actually going to create it upside down this time. Okay, now what are you going to put? You're going to have kind of 2 rows. You're going to have 2 different rows here. You're going to put numbers like up here and then numbers right there. So make sure you leave enough space. So on the top row, what you're going to go ahead and do is you're going to go ahead and just grab the coefficients of your dividend. So you're going to take this 2, this negative 5, this negative 1, and then this positive 3, and you're going to write them inside of your division symbol. So I'm going to put a 2, a negative 5, a negative 1, and a positive 3. Actually, I don't even really need to put the plus 3. I can erase that and just put the 3. Got it? Remember also, if these exponents were missing, if I did not go perfectly from exponent of 3 to 2 to 1 to nothing, then I would have had to leave a space. But in this case, since everything worked out, I can just, leave them side by side the way that I have them there. Then what are you going to put on the outside? Well, what you're going to go ahead and put is you're going to look at your divisor, and whatever value of x makes this equal to 0, that's what you're going to put in the outside. So in this case, it's going to be -3. Now, the reason why for that is because that is essentially a potential 0 to this polynomial, which we haven't talked about yet, but we'll get to later. So you can do this algebra, or you can also just take the opposite. If you see a +3 in there, then what will give you 0? Well, the opposite, which in this case is a -3. So you're going to go ahead and put a -3 on the outside. And then, oh, sorry, I'm getting a call. And then the way that you continue this, the way that you then solve it from here is super easy, but you got to pay attention. So focus, because if not, you will get lost. The first thing you're always going to go ahead and do is bring down this first leading number. So I'm going to bring down a 2. And then what you're going to do is you're going to take this 3 and multiply it with this 2, and then put your answer right here. So what is -3 times 2? Well, that is -6. Follow me here. And then from there, what you're going to do is you're going to take let me get a different color, this -5 and this -6, and you are going to add them. So what is -5 minus or plus -6? -11. Okay, so you are going to multiply and then add. Now one more time, you're going to go ahead and multiply now this again, the -3 from the outside, but this time you're going to multiply with the -11. -3 times -11, that is +33. And then you're now going to go ahead and add. Hopefully I'm not losing you here. Just remember, you multiply, add, multiply, add. So what is -1 plus 33? That gives you 32. Okay, and then once again, you multiply. So you're going to multiply outer -3 times 32. That goes ahead and gives you -96. And then you're going to add. You're going to add the 3 with the -96, and you're going to realize that that gives you -93. At this point, you can stop. Why can you stop? Well, because if I were to multiply the -3 out here again with the, this over here with the -93, and I put it right here, there's nothing to be added at the top. So that's how you know you can stop right there. So what you're going to do after you have that, what you're left over with, sometimes you're going to be left over with the 0. And what that tells you is that there's no remainder. In this situation, you do have a remainder, which would be that -93. So this is your remainder. Now, how do you then take those numbers that you just got from that multiplication? Well, go back to this original polynomial. In this original polynomial, you had 2x cubed. Over here, you had an x. The difference between, or you can just do one simple division, 2x cubed divided by x, you know that that is going to leave you with an x squared. So this is going to be your 2x squared term. This is going to be your -11x, and then this will just be your +32, and then I bring down my remainder plus -93 divided by my original divisor, which was x plus 3. And what do you notice here? This that we got using synthetic is perfectly equivalent to what we got when we did long division. Okay, I know that's kind of a mouthful and it's a lot to digest. Just take a second, look at it. Remember, in synthetic, what you do is you multiply and then you add. You multiply and then you add. You don't got to worry about these x's anymore, nothing like that. It's a quick little multiply and add. It's a shortcut. It cannot always be used, but when it can be used, I highly encourage you to use it because this is a lot shorter than doing all of this. All right, I'm going to do one more example with you guys, and then that'll be it. For the next example, I'm not going to show you how to do it by long division. I'm only going to use the shortcut of synthetic. Okay, example 2, last one. So for example 2, I am going to go ahead and want you guys to do, let's see here. Let's do 2x to the 4th plus 4x squared minus 1 divided by x minus 1. So remember, you should recognize here that you're able to use synthetic division because my degree is 1 and my coefficient is 1. All right, so let's go straight to it. So what I want you guys to do is you're going to create your little division symbol, but remember it's upside down this time. You need to fill in your coefficients of your dividend inside, and then whatever gives you 0 out here on the outside. So on the outside, if I know that this is a -1, what value is going to give me 0? Well, it's a +1. So a +1 is going to go on the outside. Okay, now let's fill in my coefficients from the inside. Here you got to be careful. You should recognize here that your exponents go from 4, 2 to nothing. So I'm going to need to leave some spaces. So I'm going to start off with the 4. With the coefficient, with the exponent of 4, my coefficient is 2. Now I do not have an exponent of 3. I am missing my 3. There is nothing there. So you need to leave a blank. But because we're doing synthetic, I'm not going to have you guys leave it blank this time. I'm going to have you put a 0 because that's my x cubed term. So that's, and then my x squared term would be a 4. I don't have an x only term. Again, I'm missing a term right here. Right here would have been the 3. Right here would have been the 1. So since I'm missing those, I need to put another 0, and then I can just finally copy over my -1. Take a second, pause. Remember, if you're confused on anything, just jot your questions down to the side. Hopefully that clarified and that made sense. All right, once you've filled in your coefficients and you've been very careful about putting zeros where they need to go, then you're going to start your process for synthetic. Remember, your first step is to just drop down that first term. That's a 2. Sorry, I'm going to put that in purple. That's a 2. All right, now we're going to do some multiplication. First, you go ahead and multiply outside times this. 1 times 2 is 2. I'm going to put a 2 right there. And then you add. 0 plus 2 is 2. Perfect. Now you do some multiplication. 1 times 2 is 2. And then you add. 4 plus 2 is 6. Hopefully I'm not losing you. Again, multiply 1 from the outside times 6. That is 6. 0 plus 6 is 6. Okay? Last one. 1 times 6 is 6. -1 plus 6 is 5. Okay? I'm done. What's my remainder? This. So I'm going to fill that in as my remainder. Now I'm going to go ahead and create re-add my x's. How do you know what variable to start off with? Well, let's look. My original was x to the 4th. I was being divided by x. What is x to the 4th divided by x? Well, that is x cubed. So this coefficient, how did I write it over here? Oh, I had done arrows. Okay. So this coefficient is going to be my 2x cubed term. This coefficient will be my plus 2x squared term. This coefficient will be my plus 6x term. This one will be my only plus 6. And then this is my remainder, so that'll be plus 5 divided by my original divisor, which was x minus 1. And that right there is your answer to this division of polynomials. I know I didn't show you guys through it with long division, but hey, if you want more practice on long division, go ahead and solve this by long division, and I promise you will get this answer. All right, so that is solving, dividing polynomials using synthetic division. It is a shortcut. Obviously, this is a lot shorter than doing all of this that we see over here. Okay, if you have any questions, make sure you jot them down. You can ask me in class. If not, then thank you for copying these into your notes, and we'll see you in class.